Today, we are going to start talking about simplifying rational expressions. A lot of what we are going to do in this lesson has to do with factoring. Right? So if you're comfortable with factoring, this should be pretty straightforward. If you're not comfortable with factoring, you're going to get a lot more practice factoring. All right? So first, okay, before we begin, let's try to remember how to simplify fractions, okay, and how to cancel out factors. So something like this: if I've got x to the fourth over x to the ninth, how would I simplify that? If I've got the same variable being divided, exactly, subtract the exponents. So what would my answer be then? If I'm taking 4 minus 9, how could I simplify this as a fraction? So one way to think about this, okay, what this really means is x times x times x times x, right? X to the fourth over x times 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 x, right?
X over x.
So yeah, if I cancel out 4 pairs of x's, I would just be left with x to the fifth in the denominator. What would go in the numerator then?
Nothing.
You gotta have something up there. Somebody said it. 1. We'll have 1 left in the numerator. So I would have 1 over x to the fifth. Okay. But the shortcut to that, okay, we don't have to write all the x's out like this. The shortcut is just subtracting the exponents. Okay, 4 minus 9 gets me that I will have x to the fifth left in the denominator. Okay. So this second example is similar, except I've got a 7 and a 42. I've got coefficients. So before I deal with the variables, what do I do with these coefficients? 7 over 42. Yeah, just divide, right? We're just thinking about this as a fraction. 7 over 42, and I just want to reduce it, right? To reduce it, the easiest way is to divide. So how would 7 over 42 reduce? What is it? 1/6, right? So I'll have 1/6. Then how would I reduce x over x to the fourth?
X more. Or it would just be x on the bottom. Wait, no, it'd be x to the third.
X to the third, right? Because if there's no exponent, we're thinking about this as x to the first. So if I want to use that strategy of subtracting exponents, I would take 1 minus 4, and I would just be left with x cubed, or x to the third in the denominator. Okay? How about something like this last one?
We'll talk about that.
We're going to talk about this one. Okay? So here we've got 2 polynomials that are factored. And I'm dividing 2 polynomials here. So whenever we have factors that are the same, okay, just like we did over here, we had factors, x and x, x and x, x and x, x and x. Okay, things that are being multiplied are called factors. Right? So whenever I have identical factors in both the numerator and denominator, I can cancel them out. So here in this example, I've got a 3x minus 5 and a 3x minus 5. Those are both the same exact factor. Okay, and they're factors because I'm multiplying. I can cancel those out. And I can just say this is 2x plus 1 over x minus 7. Okay? Is there anything else I can do now? Can I cancel out these x's? No. I cannot cancel out these x's because I'm not multiplying now, right? I'm adding and subtracting. Okay? I can only cancel things that are being multiplied. Right? And these parentheses show that these are factors being multiplied. Right? So I can cancel those out. Right? Does that ring some bells, simplifying things like that? All right. So the second part of what we're going to do today is finding restrictions, right? big idea here is that we cannot have a denominator of 0. Okay? The denominator cannot equal 0. So what we want to do is figure out the values of x that would make the denominator equal to 0 and say we can't use those. Right? So if I look at this first example, okay, I've got an x plus 2 in the denominator. What value of x would make the denominator equal 0? Negative 2. Right? So what we want to say is x cannot equal negative 2. Right? That's my restriction. Okay? Any value that makes the denominator equal 0, we cannot use. So, yeah, so we've got a symbol for that. Right? We're going to say it's just an equal sign with a slash through it. Oops, not 0. X cannot equal negative 2. Okay, now on this one, it was pretty straightforward to see that if I plug in negative 2 plus 2 is going to be 0. Right? It might be a little bit more challenging to see what value x should be here. Right? So, is there a concrete way of figuring out what value will make the denominator equal 0? Probably. Can anybody think of what that would be?
Plug in each other.
I mean, you could. That's probably not the best way, though. Any other thoughts as to how I could figure out what value of x would make the denominator equal 0? What if we just set the denominator equal to 0 and solve for x? So let's say 2x plus 5, and I'm going to go ahead and just say cannot equal 0. Right? We're going to solve this just like a normal equation. Our answer is just going to be x cannot equal whatever value we're talking about. Right? That's going to be my restriction. So to solve this, I would just subtract 5 over. So 2x cannot equal negative 5. Divide both sides by 2. And we get that x cannot equal negative 5 over 2. How about something like this, where I've got multiple factors in the denominator? What do we think we're going to do here?
Did you, do something to change them so that they're equal so you can cancel them out?
Not always. If our factored form looks like this, where none of my factors look anything like each other, there's not really much I can do to cancel factors out. Right? So I mean, this is just as simplified as we can get. But here, I just want to find the restrictions. So what I'm going to do, I'm going to take every factor and say that factor cannot equal 0. Right? So I'm going to say x plus 6 cannot equal 0, and 3x minus 2 cannot equal 0. So here, right, if I just subtract the 6 over, we get x cannot equal negative 6. And then here, add the 2, divide by 3, and we get x cannot equal 2/3. So on this problem, we get two different restrictions. Okay, two values that would make the denominator equal to 0. X can't be negative 6, x can't be 2/3. Right? Both of those would make the denominator equal to 0. So on some problems, we will have multiple restrictions. Okay? And I mean, if you can recognize those restrictions without writing this first part out, right? If you can just see, well, obviously x can't be negative 6, you don't have to write this part. You can just write x can't equal negative 6. Questions so far? All right. And let's start by simplifying rational expressions that just have a monomial over a monomial. Okay, and we practiced this a little bit. Okay, and there's going to be two parts to our answer. Right? There's going to be the simplified fraction, and we're also going to list out restrictions. So let's go piece by piece here and figure out our simplified fraction. Okay, so first I want to deal with the numbers. I've got negative 27 over 9. How can I simplify that part up?
Once you divide negative 27 by 9,
Yep.
You get negative 3, right?
You get negative 3. Should that go in the numerator or denominator?
1 over negative 3, right? What much bigger the color?
Since the numerator value is greater, negative 27 divided by 9 would just be negative 3, not negative 1/3. Right? So the negative 3 would go in the numerator. Okay, and I mean, we could write it as negative 3 over 1 if we want, just to keep things straight, okay, but we don't have to write that 1. So now let's deal with the x's. I've got x cubed over x to the 7th. How can I simplify that? X to the 4th, right? If I subtract my exponents, 3 minus 7. So should that x to the 4th go in the numerator or denominator? Denominator, right? Because the power here was larger. So I'll have x to the 4th in the denominator. Now the y's, I've got y squared over y. How can I simplify that? Exactly. We'll have y to the first power, and it'll go in the top.
Oh, I think 27 is not greater than 9. It's negative. How's it greater than 9?
That's a fair point. When we're simplifying fractions or dividing, we're, I guess, just thinking about the absolute value of that number. So you're right. What I said was actually incorrect.
It's all
Alright, so the simplified version is negative 3y over x to the 4th. Okay, we feel okay with that? Now the second part is listing restrictions. Right? So I want to think about any places that the denominator cannot equal 0 before I cancel out factors. Okay? Any variables that will make the denominator equal 0 before I cancel anything out. So if I look at my denominator, before I canceled anything, I had x and y. Okay? What value of x would make the denominator equal to 0? 0. Right? If I plug in 0 for x, I'll have 9 times 0 times whatever y is. So that would be 0. So by restrictions then, we'll say x cannot equal 0. What about y? What value for y would make the denominator equal 0? Also 0. Right. Just a little bit. Okay. So we would also say y cannot equal 0. So here's my simplified rational expression. And then my restrictions, we would say x can't equal 0 and y can't equal 0. Right. Okay so far? Do we want to do another one together, or you guys want to try a couple? Another one? All right. Let's do another one together. All right. So let's take a look at this one. 10x to the 4th y cubed over 40x to the 9th y. So we just want to go piece by piece. And let's look at our coefficients first. So 10 over 40. How could I reduce that fraction? I'm just thinking about 10 over 40 as a fraction.
Because you'll be full of
1/4. Yeah. So 10 over 40 would reduce to 1/4. Right? We're just thinking about taking that fraction and reducing it. Right? And then later on, maybe we can see if we don't need that 1. So now let's look at the x's. I've got x to the 4th over x to the 9th. How can I simplify the x's? I've got x to the 4th over x to the 9th. How can I simplify that?
We just do something like 1 over 2.
Yeah. So what's? I think you're thinking about it too much here. You're making it harder than it is. So if we've got the same variable over the same variable, what do we do with the exponents?
Subtract.
Just subtract them, right? Yeah. So if I take 4 minus 9, I would get x to the 5th. So should that x to the 5th go in the numerator or denominator? Denominator. Why? What's that? Yeah, there's more x's in the bottom, right? So that x to the 5th will go in the denominator. And then I've got y cubed over y. And remember, that's the same as y to the 1st power if there isn't an exponent written. So how would I simplify y cubed over y to the 1st? Y squared in the numerator or denominator? Exactly. So I end up with 1y squared over 4x to the 5th. Right? Now, I don't have to write this 1. Right? It's not wrong if you do. Okay? But if I show that I'm multiplying 1 times something, I don't have to write that 1. Right? So this is our simplified rational expression. Let's write down our restrictions then. So what can I say? X cannot equal what? What value of x would make the denominator equal to 0? 0. Right? I've got 40 times 0 times something. That will make the denominator equal to 0. Is y going to have a restriction? I see some yeses and some nos. So remember, we want to look at our denominator before I canceled anything out. So I want to look at this version of the denominator before I cancel anything out. So there is a y in that denominator. Right? If y was equal to 0, that whole denominator would equal 0. Okay, so we would also say here, y cannot equal 0. All right. Questions? All right, let's take a couple of minutes. You guys try these two here. Yeah. All right, we've got our answers up here on the board. All right, take a look, see how you did. Questions on either of these? Want to see any of these in any more detail?
How'd you get 3 over 4 for 18?
So I'm just thinking about this as a fraction, right? Just 18 over 24. Both of those numbers are divisible by 6. So 18 divided by 6 is 3, 24 divided by 6 is 4. So that would be how I would reduce that. You can also get your calculator to do that. If you just put 18 divided by 24 in your calculator and then do math frac, it'll give you the most reduced version of that fraction. Any other questions? All right, then let's flip over to the back. These types of rational expressions are going to be the ones that we're going to focus on a little bit more. Okay, where I've got polynomial over a polynomial. Now, remember, we said I can only cancel things out that are factors, that are being multiplied. Well, here, I'm not multiplying these things. I'm adding x squared plus 10x plus 25. So that means I cannot just cancel out these x squareds. What I need to do is factor both of these polynomials. Right? That's what we just spent the last couple of days practicing. So I want to factor this numerator. So I'm gonna come over here to the side and do some x factoring. So remember, I take a times c, so 1 times 25, put that in the numerator, put that up here in the top of the x, and then I take my b value of 10 and put it down here. So I'm looking for two numbers that multiply to 25 that add to 10, right? So that's going to be positive 5 and positive 5. Now, since my leading coefficient was 1, what does that mean? What do I do with that 5 and 5?
Just x and positive 5 and x and negative 5? I don't like it.
So they're both going to be positive 5, but since my leading coefficient is 1, that means I can go straight to factors, right? I don't have to factor by group. So I can just say that this is x plus 5 times x plus 5. Now I also want to factor the denominator. Right? So over here to my x factoring. So I've got 1 times 20 and 9. So I want two numbers that multiply to 20 that add to 9. What would we get? 5 and 4. Right? So again, my leading coefficient was just 1 here. That means I can go straight to factors. So what that means is I'll have x plus 5 times x plus 4.
We can cancel.
I can cancel one of these pairs of x plus 5s. So I'm just left with x plus 5 over x plus 4. You okay with that?
Oh, yeah.
Okay. Now the second part is listing restrictions. So I want to look at my version before I canceled anything. Okay. And I want to look at what values will make the denominator equal 0. What value of x will make the denominator equal to 0. So I've got two factors here before I canceled anything out. So I'm going to have two values of x that will make the denominator 0.
5 and negative 4.
Negative 5, negative 4. Exactly. Right? So if you want, you can write that out. You can say x plus 5 cannot equal 0. Subtract the 5. Right? And we get x cannot equal negative 5. We get a similar thing here. X cannot equal negative 4. If you can recognize that without doing this work, that's fine. Right? So just write it over here then. Say x cannot equal negative 5, and x cannot equal negative 4. Okay, so this is my answer. Right? The simplified fraction along with restrictions. Right? Questions? Yeah, let's do another couple of them together here. All right, so let's take a look at B. So we didn't do this on the first one, but remember, the very first thing that you should always look for is what? GCF. Before you even think about x factoring, look for a GCF. Exactly. On both of these, I can factor a 2 out before I do anything. So what I do there, I would say this would be 2 times, and I'm just going to divide each of these by 2 then. So that'll be x squared plus 4x minus 12 over 2 times, I'll be left with x squared minus 4x plus 4. All right. So now, I want try to x factor both the numerator and denominator. So in the numerator, I'm looking for two numbers that multiply to negative 12 that add to, that add to 4. What could we have that multiplies to negative 12 and adds to 4? Okay. Yeah, we're going to be using 6 and 2. One of them is going to have to be negative, though, for them to multiply to negative 12. So which one should be negative? The 2. Right? 6 plus negative 2 is 4. 6 times negative 2 is negative 12. So my numerator then would be 2 times x plus 6 times x minus 2. I want to do the same thing for the denominator then. Right, so I'm x factoring, and I want two numbers that multiply to positive 4 that add to negative 4. Right. Negative 2 and negative 2. Right. Negative 2 plus negative 2 is negative 4. Negative 2 times negative 2 is 4. So my denominator then would be 2 times x minus 2 times x minus 2. So what can I do now? I can cancel out these x minus 2's. And I can actually also cancel out these 2's, right? Because these are being multiplied. These are factors that are exactly the same. So I can cancel out the 2's as well. And I'm just left with x plus 6 over x minus 2. Now, what would my restrictions be? Before we get rid of anything.
Positive 2.
Say x cannot equal positive 2. And if I plug positive 2 in here, 2 minus 2 would be 0. What about this one? Same thing, right? I can't have positive 2. So I don't have to write it again. Right? If I just get the same restriction from both of those, I would say x cannot equal 2. Right? And so that would be my only restriction here. Right? That's the only value of x that would make the denominator equal to 0. So that's my answer. X plus 6 over x minus 2, and x cannot equal 2. Questions? Alright, let's do this one together here. Alright, so here, again, first thing we want to do is look for a GCF, either the numerator or denominator. Well, I've got a 1, a 4, and a negative 5. There's no GCF there, right? Then I've got 3, negative 10, and 7. Is there a GCF there? Yeah. Right? So, I'm just going to have to factor. So if I factor my numerator here, come over here and do my x factoring. So I want two numbers that multiply to negative 5 that add to positive 4.
1, negative 1. Or negative 4, negative 1. You gotta get it all the way down. You want to.
I want them to multiply to negative 5 and add to positive 4.
Negative 1 and 5.
Yeah, negative 1 and 5. So again, since my leading coefficient was 1, I can go straight to factors and say this will be x minus 1 times x plus 5. Now my denominator has a leading coefficient that is not 1. Right? That means when I x factor, I'm going to have to do factor by grouping. Right? So here, let's x factor. So up here, what am I going to put up here? What is it? 21, right? 3 times 7. And then down here, put my b value of negative 10. So I want two values that multiply to 21 that add to negative 10. So, I mean, if we can't think of them,
7 to 3.
yeah, it's going to be 7 and 3. Right? But we could list out the factors, right? We could say 1 times 21, 3 times 7, right? There aren't a whole lot of options, right? It looks like 3 and 7 are going to work out here. Positive 3 and positive 7? Both of them negative? Yeah, they're both going to have to be negative, right? So now, since my leading coefficient was not 1, I cannot go straight to factors, right? I have to factor by grouping. So, what I'm going to do is say this is 3x squared minus 3x minus 7x plus 7. And now, I group, right? So I group the first two, group the second two, and look for a GCF. So here, 3x squared minus 3x, what can I take out of both of those terms? What can I take out of both the 3x, or 3x squared and a 3x? 3 and an x, right? So if I take out a 3x, here I would just be left with x, and here we would have minus 1. So now in my second set, I get negative 7x plus 7. What can I take out of both of those? Yeah, we want to take out a negative 7. Right? So if I take out a negative 7, I would be left with x. And then here, if I'm taking out a negative 7, what that means is we're dividing. So I would do 7 divided by negative 7. That would be minus 1. So now, since I'm at this stage and these two factors are exactly the same, my answer then is that factor, x minus 1 times 3x minus 7. So now, I can come back up here and say this denominator factors into x minus 1 times 3x minus 7. Now what can I do? Cancel out the x minus 1s. And I just get x plus 5 over 3x minus 7. Now we have to do our restrictions.
For sure, positive 1.
For sure, positive 1. Right? This one will give me positive 1. What about this one here? How would I figure that out?
That would do 3x minus 7 trying to equal 0. Bring the 7 over, divide the 3, and then answer.
Exactly. Right? We just say 3x minus 7 not equal 0. Add the 7 over. 3x cannot equal 7. Divide by 3. We get x cannot equal 7 over 3. So that is my other restriction. So this is my answer. X plus 5 over 3x minus 7, where x cannot equal 1 and x cannot equal 7/3. Feel okay? So again, most of these problems are the factoring part. Right? The only really new thing is once we have it all factored, look for anything that's the same in the numerator and denominator and cancel those out. And then also writing our restrictions. Okay, what values would make the denominator equal 0. All right. I'll do one more together. Let's jump to E. We'll skip D for now and take a look at E. Alright, so on this one, again, we have to factor. So in my numerator, let's look for a GCF. 2, negative 9, and 10. No, right? No GCF. Bottom one there is, right? So right off the bat, we could go ahead and simplify the bottom. So if I take out a 4, I would say this is 4 times what?
X and then negative 2.
X minus 2. Exactly. So the denominator, bless you, is already totally factored. Okay. So now we just have to look at the numerator. So I'm going to have to x factor. So I'll come over here to the side and do my x factoring. So up here, I will have 2 times 10. So that's 20. Down here, I'll have negative 9. So I want two numbers that multiply to positive 20 that add to negative 9.
-5 and -4.
Negative 5 and negative 4. So again, since my leading coefficient is not 1, I have to factor by grouping. So that means this will become 2x squared minus 5x minus 4x plus 10. And then I'm just going to group the first two and the second two. So looking for a GCF here between 2x squared and negative 5x, what would I have? Is there a GCF between 2 and 5? No, there's no GCF between 2 and 5, right? So I can't take a number out, but I can take an x out of both of these, right? So I could say this is x times 2x minus 5. Now in my second set, I've got negative 4x plus 10.
2.
I could take a 2 out. Now, since this first one is negative, I'm actually going to take out a negative 2. So if I take out a negative 2, remember, that means we're dividing. So I would do negative 4x divided by negative 2, and that would be positive 2x. 10 divided by negative 2 would be minus 5. So at this stage, these are exactly the same. So my final answer then is 2x minus 5 times x minus 2 for this factor. So now I can take this and put that up here in my numerator. So I can say this is 2x minus 5 times x minus 2. I can cancel out the x minus 2's now. And I get 2x minus 5 over 4.
X can't equal positive 2.
And x cannot equal positive 2, exactly. Okay.
Bam! He does it again.
Alright, so tomorrow we'll do practice. We probably won't be here Wednesday or Thursday. And then